Hello friends, welcome to EMTECH channel. This is yet another video in this channel. In this video we are going to discuss about the current transformer. I have already made a video on current transformer previously based on its constructions and how it will look like from outermost part to the innermost part. I have made that video and I am giving that link in the description below. Please do watch it, and I am giving an iCard also so that you can check to that video. And if you like this video, give a like, comment, share and subscribe the video. And let's go on inside without wasting the time. And in this video we are going to see about type, VA, class, ratio, STR, HSV or LSV, SV and ILV and ISF. And in this video we are going to skip this frequency and manufacturing year and the serial number and this standard, because frequency everyone know in India the supply frequency is 50 Hz and the manufacturing year is not that much importance for this video, and serial number is also not required. It is based on the company specificities, and this is the standard on which this CT is made, and I will try to make another video on about this standard. And now let us discuss the remaining part. First we will discuss about the type. So what is type? It defines the construction of the transformer. There are three types of current transformer based on the construction. One is wound primary, and second is a bar type, and third is a toroidal or rectangular type, and each have its own abbreviations. And in this particular current transformer it is given as type WPL, means it is a wound primary current transformer. What is a wound primary? This is an example of a wound primary type current transformer. You can see here in this it has both primary windings and secondary windings. So it is called as a P1, P2, and the secondary terminals will be called as S1 and S2, and the main line that comes will come to this point, it will be terminated at here P1, and it will take the output wave from P2, and based on this the current flowing on this winding S2 will generate, secondary will generate its own current based on the CT ratio. So this is the primary winding you can see here, and this is the secondary winding. And next we are going to see about VA. So next VA, what is VA? It represents the rated burden of the current transfer. Burden is nothing but the load connected to the secondary of the current transfer, and its unit is VA. Unlike the power transformer, in which the secondary of it serves for the actual load, that is for a motor or some equipments or some pumps, secondary of the current transformer serves only for a metering and protection. So to differentiate the actual load and the load that is being supplied by the current transformer secondary, so to differentiate that, a name introduced, it is called as burden, and all the loads that is connected to the CT secondary will be called as burden, and its unit is represented as VA. So for example, here core 1 given as 15/0.5 means VA is 15. So VA 15 in this current transformer mean it can withstand 15 VA in current transformer secondary, means it can serve the load up to 15 VA. And next comes the class, and it is the most important point in respect to the current transformer. In this type you can see here two type of classes are available. Here two cores are there, means this current transformer has two core and it has different designations. Here you can see here it is somewhat written as 5P10, but here it is given as 0.5. So the Planck representation number means it is a metering type class, and it is this core is designated for metering. Class or accuracy class of a current transformer is the highest permissible composite error that the CT can produce at the rated current. And the composite error you can see here it is 0.5. 0.5 means the manufacturer says that this CT will produce only error of 0.5% the rated current. Means what is the 0.5% error? It is said as a composite error. And what is a composite error again? Composite error is the difference between the theoretical sinusoidal current to the actual current that the CT intakes. It is called as composite error, and this CT can give 0.5% error. That means can work with 99.5% accuracy. Standard accuracy class will be 0.1, 0.2, 0.5, 1, 3, 5 for metering CTs. So when the accuracy classes are becoming less means the CT will be more accurate. For example, if you take this 0.1, it means that the manufacturer says this CT at the rated current produces only 0.1% of the composite error. So, for example, if CT is of 0.5 accuracy class, it means that the maximum permissible limit of the error is only plus or minus 0.5% for 100% rated current. And second, now we have seen about the metering type course accuracy class, and now we will going to see about the accuracy class for protection type. In protection CT, the accuracy class is defined in the following format. Here you can see here the accuracy class of a protection CT is 5P10, means the first letter 5 defines the percentage composite error, and next comes the P, that is a designation for protection type, and next comes 10. 10 is the accuracy limit factor. Already we have seen that composite error is the difference between the ideal RMS current to the actual current that is intaken by the current transformer. And here 5 means 5% composite error. That means the CT protection type will produce maximum of a 5% composite error for the rated current, and 10 indicates accuracy limit factor. The accuracy limit factor is a measure that the manufacturer says this CT can maintain its accuracy up to 10 times of the primary current. You can see here it is accuracy limit factor is the rate multiple of the rated current up to which the accuracy will be maintained provided the rated burden is connected. Here 15 VA is the rated burden. In this case 10 means up to 10 times the rated primary current, as I said before. So CT will function perfectly within the rated composite error provided the burden is connected. So next we will see about the ratio. Ratio is the one that is defined as the ratio between the current in primary to the current in secondary. It is also called the Stern's ratio also. Means suppose your CT ratio is set to be 500/5. You can see here you can apply this here. So current in primary equal to 5 amps, 500 amps, and current in secondary is 5 amps, and the answer we will get is 100 amps. Means if 100 amps current flows in primary, 1 amps will be generated in the secondary. So if we take this as an example, 500/5, so when 500 amps flows in the primary, only 5 amps will be generated in the secondary. In this figure, it is a dual core CD. You can see here the ratio is given as 80/40/5/5 amps. Means suppose if the circuit is of 80 amps, you have to connect it to the first core, and suppose if the circuit is of 40 amps, you have to connect it to the second core. Here you can see that as accuracy class is given as for core 1 it is of metering type, and core 2 is for protection type. So we can use it as per our application. Next comes STR. STR is the short time rating. It is the measure given by the manufacturer that this CT can withstand this amount of current for this amount of time. Here you can see that it is given as a 26.3 kA, and the seconds is given as 1. This means that this CT can withstand 26.3 kiloamps of current for 1 second before getting totally damaged, before getting its insulation failure. This CT can maximum withstand 26.3 kiloamps for 1 second. Next comes SV or NSV oblique HSV. Next comes SV or NSV slash HSV. Means SV means system voltage. In some manufacturers they will mention it as NSV. NSV means nominal system voltage. It is the normal working voltage of the system. And HSV means highest system voltage. This is the voltage up to which this CT can function without any issue. Next comes ILV. ILV is called as insulation level voltage, and in some cases it is mentioned as VIL. VIL means basic insulation level. It is the magnitude of voltage which it can safely withstand between primary to secondary, or between primary to earth, or between the secondary to earth. This means that this is the maximum amount of voltage that this CT can withstand between primary to secondary, or between primary to earth, or between secondary to earth under fault conditions without any breakdown in its insulation. The first value represents the RMS voltage. It is sometimes this can occur due to earth fault. So it means that this CT can withstand up to 70 kV RMS voltage between the primary to secondary, or primary to earth, or secondary to earth. And the second comes 170. 170 means impulse voltage, that is maximum lightning impulse voltage. this amount of voltage 170 kV, it can stand between primary to secondary or primary to earth or secondary to earth for some short durations without getting insulation getting damaged. Here 70 kV is the RMS voltage and 170 kV is the lightning impulse voltage. Comes ISF. ISF is called as an instrument safety factor, and it is a ratio of instrument limit primary current to the rated primary current. This is a measure of the amount of current that the CT can safeguard against its protection device. And for example, suppose if there is a fault in a primary and the primary current goes high, due to the ratio, the CT secondary will also receive a high current. If CT rated for 100/1 and its ISF is less than 5, manufacturer defines as ISF less than 5, and suppose when a fault current occurs, the CT can protect the instrument connected to it up to the fault current of 500 amps. When 500 amps of current is flowing, the CT will receive up to 5 amps. So up to this 5 amps, the CT can safeguard the instruments and the protection relays connected to it. Guys, we came to the end of this session. Hope you enjoyed. If you like the video, do like, comment, share and subscribe the video, and don't forget to press the bell button next to it so that you will receive all the notifications whenever I posting a new video. Thank you friends. We'll meet in next video. Bye.